This is Gail Kovac for Gresham Barlow School District. This is Summer School, High School Credit Recovery, Algebra 1A, and Learning Target number 13. I can solve systems of equations using elimination. So we've learned that systems are more than one line or curve. And the solution to those systems is where do they cross? The coordinates x and y for values that work in both equations at the same time. We looked at just graphing the lines, looked at algebraic way, which is substitution. That is mashing the equations together in some way that you only get just x's or the x's left, and then you solve for x, and then you go back and solve for y. And substitution is the more complicated way of doing it. This one's my favorite way, elimination. Now, what's important in elimination is it's called elimination because what you want to do is mash those equations together so that one of the variables, either x's or y, just drops right on out, disappears, gets eliminated. And for elimination to work, you need to have all of the like terms stacked on top of each other. X's, Y's, equal signs, and constants. X's, Y's, equal signs, constants. Now you could have Y's, then X's, then equal signs, constant. That's fine too. But this is different than substitution because we had Y equals. At least one Y equals will do, but in this case, we don't have any Y equals. So just like we can do things like add constants together, like 132 plus 64 or something, we have the ones stacked up, we have the 10 stacked up, and the 100 stacked up, and then we could just add those together straight down, right? Or we could subtract them as well. Well, we're going to do the same thing, but they're going to be with big equations like this. So let's see what happens if I were to just add these two equations straight down. All right, so I'm going to get 19 plus 9, which is 28. I'm going to get 1y plus 6 more y's. That's positive 7 y's. And I'm going to get negative 3x plus 3x. That is 0 x's. And that 0 is very important. I have no x's. They have been eliminated. And that's because negative 3x and positive 3x are additive opposites. They cancel. Those are gone. So really, I don't even need the 0 x's. They have been eliminated. Now, when I mash these equations together, I get just one equation with one unknown. That's y. And you know what? I don't even need the plus sign anymore. That's 7y's. 7y equals 28? That's easy to solve. All I have to do is get rid of that coefficient of 7, and I'm done. So, times by 7, I'm going to divide by 7. Both sides. Those will cancel. And y will be equal to 4. 28 divided by 7 is 4. And I have already found the y component of the coordinate of where those two lines cross. It's 4. That was a lot less work than substitution. However, that's only half the answer. I need to find x as well. And to find x, I'm going to use one of these two equations up here. It doesn't matter which one. I don't know. Which one should we do? I don't like this negative up here. Let's do the bottom one. I'm just going to choose the bottom one. All right, and I know what y is. Y is 4, so I'm going to put that in for y right here. All right, 3 times x plus 6 times y equals 9. And that y that I found previously, I'm going to put that in for y right here, 4. All right, let's clean this up. And now I just have x's so I can solve there. This is going to be 3 times x plus 6 times 4 is 24. That equals 9. All right, let's get rid of that constant of 24. I'm going to subtract 24. And then I will get 3x equals whatever 9 take away 24 is. We do 9 take away 24. That is negative 15. All right, last step to solve for x is to get rid of the coefficient, that multiplier of 3. I'm going to divide by 3, divide by 3. X is going to equal, what is that, negative 5? Negative 5. So that's going to be my first answer right here, negative 5. So these two lines, once they are graphed, would cross at negative 5 for x and 4 for y. All right, let's try it for the next one. So I am going to add these equations together and see what happens. Hopefully something gets eliminated. All right, 10x plus 10x gets you 20x. 9, negative 9y, negative 4y, that's negative 13y. And that's going to equal, gosh, 28 and 18. Is negative 46 altogether. Let's see. Uh-oh. I can't solve this. I've got x's and y's. Nothing got eliminated. Well, shoot. It's because I don't have any additive opposites. This did not add up to 0. Neither did that. Neither did that. So the x's and y's are still there. Man. Oh. What if I had subtracted the bottom equation from the top instead? Then I would get 10x's minus 10x's to get me 0x's. Ah, that's what I need to do. I'm going to subtract instead. Let me try that again. All right, let's see here. Let me do subtraction, and I'm going to subtract this entire thing. Okay. 10x's, take away 10x's, there's the 0x's that I need. Ooh, but now I've got something tricky to do. I've got to do negative 9y, take away negative 4y. To subtract a negative, that's the same thing as adding a positive. So this is going to be 9 instead of minus 4y, it's going to be negative 9y plus 4y. That's going to get you negative 5y's altogether. Watch out for those tricky negatives. Geez. And now this is going to be negative 28 minus negative 18. That's like negative 28 plus 18 instead of minus 18. So negative 28 plus 18, that's going to get you 10. Ooh, negative 10. Got to be careful with those negatives. Negative 10 altogether. And there we go. There's those 0x's that I wanted. I have an elimination that happened here with the 10x's take away 10x's. So I don't even need to bother to write the 0x's at all. Now I've got a simple equation to solve. I can do this one. Whoops, wrong color. I'm going to be picky. All right, I want to get rid of this coefficient of negative 5. That multiplier needs to be divided. Divide each side by negative 5, divide by negative 5. Oh, I already know what y is. Y is going to be equal to negative 10 divided by negative 5 is 2 altogether because these just canceled out. All right, so now I've already got half of my answer. I know that y has to be 2. Now I got to figure out what x is. But again, you can pick either of these original equations and just put 2 in for y to solve for x. And I'm going to pick, I don't know, let me pick the bottom one because I guess it's smaller than 9. 4 is smaller than the 9. I don't know. Doesn't really matter whichever one you pick. All right, the original bottom one was 10x. Take away 4 times y equals negative 18. But now I know what I'm going to use for y. I'm going to use this for y right there. 2. All right, let's clean this up a little bit and solve for our x. I've got only x's left. I can do this. 10x take away 4 times 2 is 8 equals negative 18. And let's see here. Let's get rid of that constant at the back first. I'm going to add 8 both sides. So now I'm going to be left with 10x equaling negative 18 plus 8, that's negative 10. All right, last step here. Let's get rid of that times by 10 by dividing by 10. Boom, gone. What is x equal to? Well, let's see. Negative 10 divided by 10 is negative 1. All right, I got my second part. That's negative 1 for x and 2 for y. I'm really glad I didn't have to graph that because, gosh, look at these big numbers and x-intercepts and y-intercepts. I mean, you could always do it that way, but if you're more of an algebra person, this could be a good method. The only thing you need to know here is if you should add or subtract the equations together. Firstly, if they're all stacked up like this with x's, y's, equal signs, and numbers all grouped up, that's a suggestion you might need to use elimination. If you've already got additive inverses, positive 3x and negative 3x, positive 17x and negative 17x, as long as it's the same number in front, one's positive and negative, you're ready to just add those together. However, if they're the same coefficient with the same sign as well, both positive or both negative, you're going to have to subtract one from the other instead. Just watch out for which one's getting eliminated. It doesn't have to be the x's that get eliminated. If this were negative 6y, then I could cancel those and solve for x first instead. It doesn't matter which one you solve for. As long as something's getting eliminated, so you can solve for one, plug it back in somewhere to solve for the second one, then you've got your x, y, and that is where the lines will cross.